is Annette Lund. I'm the Vice President of Diversified Plastics. We're a contract manufacturer specializing in custom injection molding. We work with some medical device customers where we do some assembly for them in our Class 8 clean room. We're also working with lithium-ion batteries, aerospace, avionics, and defense. We just bought a Stratasys Objet 260 Connex PolyJet 3D printer just 5 months ago. We have a lot of customers that are interested in us building prototype tooling. So we do aluminum and P20, but they're very time consuming. They can take weeks to build, and one of our customers needed to get to market much faster than that. So by being able to print the mold components and put that in the press and run it, we can do it in a matter of days instead of weeks. So that's been very helpful. And it's actually less expensive. They're able to get a few parts to test out their design so that they can move forward and see if that design is going to work.
My name is Joni Davis. I'm with Diversified Plastics. Currently I'm working with a medical OEM here in the Twin Cities area, and they make product for urology, and we do quite a few medical devices for them. They came to us with a situation where they were launching a new product to the market, and they wanted to test out the design before it actually went into a production tool build. Working with the medical industry, there's a lot of materials that are specifically approved by the FDA. Especially in the thermoplastic elastomers, you don't have a lot of opportunity to do prototyping. So what happens is they can't machine it, they actually have to build a steel tool, either an aluminum or a soft steel tool to get parts, and the time we could work on this for 6 weeks to get them apart. They got apart in 5 days. And so to be able to grow or print these cavity and core blocks and get the exact material that's already been approved for their product, they can do sterilization testing, and they can also make the changes too. If you bring them apart and it's not exactly the color or the texture or the feel that they're looking for, then they can go back to the drawing board and go back to their R&D group and say, we need to look at changing the texture, changing the design, changing the color or the material itself. When we're looking at comparing costs between the 3D printed cavity and core blocks versus AP20 tool steel, which we would usually use in a prototype process, printing the product, we have an existing mold frame for this particular core block and cavity is about $1,800. If we were going to do it in the P20 tool steel, it would be closer to $10,000. We have found with experience that it is the way to go, especially on a thermoplastic elastomer. This is the only way you're going to be able to get an actual part to your customer in a prototype method.
We're excited about the whole PolyJet technology for TPE, polyethylene, polypropylene. It's an excellent way of getting product to market very quickly.